Hey everyone, welcome to the boring head build that's kind of like this old Tony's, but worse. I think the very last machining project I did before I started making videos was a miniature boring head to use in my little machine shop mini mill. The design was sort of organic. It started out as a very simple tool with no fine adjustment to cut some circles in a sheet of plexiglass for a project with my 8-year-old. It was so close to being a proper boring head at that point that I modified it to have an adjusting screw and a couple different tool orientations. The size was very well suited for the type of work I usually do in the small mill. I made it with a straight 3/4 inch shank to be used in an R8 collet and made it to accept 1/8 inch round tooling. The OD of the body was a little over 1 inch, a pretty small boring head for sure. It wasn't long after I started doing videos that I found myself wanting to make a second boring head of a bit better design as the subject for a video. The problem was I didn't really need another one. When it came time to think about making Christmas presents for some friends and relatives, I immediately knew I had to make this boring head for my buddy Justin up in Canada. So finally, you guys get to see a totally different type of boring head. The obvious starting point was making the two halves of the body. I didn't use anything special for this, just some cold-rolled steel from the scrap bin. I started by turning the 3/4 inch straight shank. You can see the bird's nest of chips I'm getting under heavy cuts here. I think this old Tony's recent video about grinding high-speed steel tooling must be a sign that it's finally time for me to grind up a better selection of turning tools for the old rivet here. I've got a couple of go-to turning tools I use in this lathe, and neither one of them's very good for chip control. I reversed the work in a 4-jaw chuck and dialed it in true to a reference surface that I had left on the larger diameter of the part. This is just to true up the surface where the female dovetail will be cut. And you can see I'm using some slips of paper to protect the work from the jaws of the chuck a little bit. And now a few quick facing cuts on the part that will become the bottom half of the boring head. And this is the surface that will receive the male dovetail. The next feature to be machined is the female dovetail in the top half of the boring head. We're taking it over to the mill and we'll start by milling a slot through the center of that surface and then following it with a dovetail cutter. Maybe you've heard me say this before, but I love these 3/8 inch diameter roughing end mills. They're ideal when you need to take off a lot of metal using these small mills. As you'll see, the design of this boring head is a little bit different from most. Instead of having a half set of threads set inside one of the halves of the boring head, this design uses a full brass nut. Because of the design, the adjusting screw needs to sit completely down inside of the male dovetail. Maybe that doesn't make sense, but I think it will be clear as we progress here. Because of this, I'm sort of limited to the size of dial I can use on the end of the adjusting screw. I'm, limited to whatever can fit within the confines of that male dovetail. And since I only have a very small dovetail cutter, that really limits the size of this dial. If I were to make another one of these, I would certainly get a larger dovetail cutter to give me a little bit more room for a larger dial. At some point in between facing the end of this part and putting it in the mill to cut the dovetails, I decided that I had left a little bit too much meat. So here I'm just taking a little bit more off of the surface. And now a couple of quick passes with the fly cutter. Now we need to mill the mating male dovetails, and this is where it gets a little bit trickier, because we have to cut dovetails that fit the existing female dovetails in the other part. This isn't meant to be a tutorial on how to measure and fit dovetails, but in a nutshell, you measure female dovetails by placing a pair of matching pins inside the dovetails and measuring in between them, and measure male dovetails by again placing matching pins in the dovetails and then measuring over them. Now in the same setup, we'll find the center and then mill a pocket to receive the adjusting screw. This pocket will provide clearance for not only the adjusting screw, but the mating nut as well. And now just some quick deburring. The adjusting screw was turned from some 01 drill rod. The threads are number 540 and were cut using a split adjustable die using this handy Horth tailstock die holder. Just ahead of the threads on the adjusting screw is a bearing surface. This needs to be a pretty nice fit inside of a bore in the body of the boring head. The head of the screw is going to be two pieces. To start with, it's going to look pretty much like your run-of-the-mill slotted screw head. And later on, we'll make a graduated ring that will be a pressed fit over the screw head. To slot the head of the screw, I just transferred it into a collet block and took it over to the mill and used a cheap slitting saw. That's it for the basics. So now we've got both halves of the body basically machined with matching dovetails. We've got an adjusting screw, and we've still got a lot of details to take care of. Lots of fiddly stuff to do, some involved setup. So tune in next time and we'll go through machining the fixed gib, the brass adjusting screw nut, the graduated dial for the adjusting screw, and all the other little details.